In the year 1519, Ferdinand Magellan embarked on a voyage of discovery that would reveal the dimensions of our world. Today, thanks to a project that bears his name, a new facility is allowing astronomers to begin a different kind of adventure, opening a powerful new eye on the mysteries of the heavens. At a laboratory under the University of Arizona football stadium, technicians load a truck with a strange container. Inside is an enormous mirror, measuring 6.5 meters across and weighing 21,000 pounds. It's bound in a convoy on a 6,000-mile journey to a mountaintop in Chile, the site of the Carnegie Institution of Washington's Las Campanas Observatory. The mirror is the largest piece of a powerful new telescope for the Magellan Project, a multi-year effort to build a facility that will make possible a host of important discoveries.
The Magellan telescope is going to be a revolution in studying how galaxies form by the direct observation of galaxies far away and long ago, taking advantage of the fact that light has been traveling to us for such a long time that when we look far out into space, we look back into time.
I've used bigger telescopes not to look farther, but to look in greater detail at things near us. There's still many, many things we don't know even about the nearest galaxies.
Magellan is a wonderful opportunity to lock down all the remaining nearby stars that will form the basis of virtually all future studies of extrasolar planets.
And it's telescopes like Magellan and the successors to the Hubble Space Telescope that I think really are going to allow us to answer these questions in detail.
This journey actually began with the founding of the Carnegie Institution of Washington, established in 1902 to advance the cause of scientific research.
Carnegie has a very long and proud tradition in astronomy, going back to the beginning of the century when Carnegie built the world's largest telescope at that time, the 60-inch telescope on Mount Wilson, and then followed it up about a decade later with the new world's largest telescope, the 100-inch telescope. And it was, in fact, with that telescope that Hubble discovered the most important discovery of the century, that we live in a galaxy amongst millions of galaxies, and that the galaxies are all expanding apart.
Carnegie scientists have traditionally had the world's most powerful telescopes with the best instrumentation. They have also had an environment of concentration on their work and freedom from other distractions, and availability of those resources at a level that is really extraordinary in the world of science. And that has paid off for us.
You know, the history of astronomy in certainly the first half of the 20th century was the history of this observatory. And that changed over the last 15 years, where this observatory no longer had access to the largest telescopes. And that was an uncomfortable change.
For the past 3 decades, the Las Campanas Observatory served Carnegie astronomers well. But by 1986, they realized that they would soon need even more powerful telescopes to answer the questions raised by their research. When it's completed, the Magellan Project will add not just 1, but 2 telescopes to the Las Campanas Observatory. The first has been named for German-born astronomer Walter Baade. The second, in honor of Landon Clay, a generous supporter of the Magellan Project.
There are real advantages to having 2 telescopes that are essentially similar. You can optimize one for observations with visible light and another one for observations with infrared radiation. And also, off in the future, there's the possibility of combining the light from the 2 telescopes, which gives you some of the power of a telescope with a diameter equal to the distance between them. And so we realized we couldn't do that alone, that we needed to look for other partners.
The University of Arizona was the first of the partners to join with Carnegie on the Magellan Project. Later, Harvard University, the Massachusetts Institute of Technology, and the University of Michigan joined the team. Each partner has contributed substantial funds to the Magellan Project, as well as vital skills in telescope or instrument design.
We were wonderfully fortunate in gathering together a group of institutions that were compatible with us in the kinds of science they do and the way they go about it, and have strengths that both fit with Howland and also are complementary in terms of their particular interests and their particular expertise.
The University of Arizona's Steward Observatory Mirror Laboratory took on the challenge of manufacturing the primary mirrors for the two telescopes. Each mirror had to be big, so big that it could collect enough light from objects at the outer reaches of the universe to make their faint features visible. Each also had to be perfectly smooth, smooth enough to reflect images of those distant objects without distortion. But how do you shape a curved surface that large so that it accurately focuses the light it collects from any point on its surface? By spinning it while the glass melts in a special rotating furnace, using centrifugal force to create what human hands and machinery alone cannot. Then it's a matter of polishing and careful inspection. One drawback to a mirror this accurate, it's fragile. Because even the slightest damage to the Walter Baada's primary mirror could make it useless. Transporting it safely thousands of miles to a mountaintop in South America was a daunting challenge. Inside the mirror's protective casing, instruments were installed to monitor its temperature and the effect of even the smallest bump in the road. Then began a different kind of journey, a 17-day voyage by sea to Chile, home to one of the best locations on Earth for viewing outer space.
Is one of the few places where you get a view of the sky and a view of the southern Milky Way that is really breathtaking. You really have the feeling that you're standing off in space looking at a galaxy, and that is our galaxy.
The other aspect of being in Chile is that the conditions are really exquisite. And I don't think there really is a comparable site in the Northern Hemisphere.
Something similar happens on the west coast of the United States. But of course, the big difference in Chile is that there's very little light pollution down there.
And the quality of the site is so important to the observations you make that it's a huge advantage to be at the very, very best site.
Arriving safely in Chile, the mirror was readied for a still more challenging trip. This one over the difficult terrain of Chile's north-central highlands. The Chilean government has generously allowed astronomers from other countries to do research in Chile's Andes Mountains for many years. Chilean astronomers benefit as well.
Carnegie has made a point of working with Chilean astronomers. So right from the beginning, we committed that 10% of the time on any telescope we built would belong to Chilean astronomers.
Time for observation is the lifeblood of modern astronomers and one of the principal considerations driving the Magellan project.
Many of the other telescopes are run by very large international consortia with hundreds and hundreds of astronomers who want to use the facility, and then maybe astronomers can only get 1 or 2 nights a year. And there are a lot of projects that you can't attack with such a limited access to the facility.
23 days after it left the Steward Observatory Mirror Lab, and none the worse for its travels, the mirror reached the Las Campanas Observatory. Now it could be added to the many other complex parts that would make up the Walter Baada telescope. Telescope technology has changed a lot since 1920.
The differences between the Mount Wilson 100-inch telescope and the Magellan telescope is night and day. The 100-inch telescope was a massive structure capable of keeping the mirrors in position just from brute force. It was all big relay logic. It was a mechanical nightmare. The 100-inch telescope required no computers. Magellan requires of order 10. And just to make it point.
But today's telescopes are much more than mirrors and control systems.
It's now gotten so that instrumentation is almost as important and almost as costly as a telescope.
One instrument that will be used with the Magellan telescopes is the Inamori Magellan Aerial Camera and Spectrograph, or IMAX.
This IMAX spectrograph, which is a very wide field which allows you to take the spectra, spread out the light into its colors of hundreds of maybe even thousands of galaxies at the same time. So it's possible to spend a very long time because these objects are very faint, and you can afford to do that because you do 1,000 at a time.
Instead of focusing on wide areas of the sky, Echelle spectrographs were designed by Carnegie and Harvard astronomers to measure the motion and chemical content of individual stars and galaxies in high resolution. Even a subtle wobble in a distant star can be evidence of an orbiting planet, maybe one that harbors life.
We need, as you can imagine, extremely high resolution and extremely large wavelength coverage. And we are very fortunate at Carnegie to have Steve Scheckman, who is one of the world's genius instrument builders. And he is currently in the process of building 2 such Echelles for Magellan, and we are hopeful of using them both for the Planet Search program.
As the Magellan facility evolves, it will be equipped with an ever-increasing complement of specialized instruments. This variety of instrumentation will allow the Magellan telescopes to do things that other telescopes cannot, not even space-based telescopes, such as the Hubble.
Space affords you the opportunity to get very high resolution because you don't have this problem of the Earth's atmosphere and the turbulence. But you can build bigger telescopes on the ground, and so if you'd like to get spectra, for example, and disperse the light that's coming from an object, you want a larger collecting area, and that you do well from the ground.
Still, space-based telescopes can see parts of the electromagnetic spectrum, such as X-rays, that terrestrial telescopes simply cannot.
And when you look in the X-ray, you see sometimes completely different things than you'd see in the optical. And in fact, we're finding lots of objects in our X-ray images that we hadn't previously seen in the optical. And so what you need to do, though, is to really learn what they are. You have to go back and look at the stars in those systems, which you can only do with the big telescope like Magellan.
On September 15, 2000, the Walter Baade telescope saw first light. Astronomers' first glimpse of the universe as captured in its mirrors. To untrained eyes, these images may not look impressive, but to astronomers, they're a tantalizing hint of the answers that may now be available to some of our most important questions.
When did the first stars form in the galaxy? How did the disk of our galaxy begin to form? Was that disk born early on when the very oldest stars, which we know go back to within a couple of billion years of the Big Bang, or did that happen much, much later? How did the enrichment of chemical elements proceed in the early days? When did it rise to a level where you could actually make planets and life? They get quite detailed, these questions, but they're all crucial to figuring out how the galaxy was put together structurally, dynamically, and chemically.
There'll be 50 people using Magellan as soon as they can, and they'll have 50 different ideas of what you can do with it.
Almost everyone in this building has a long agenda of things they've been wanting to do for many years, and that Magellan is finally going to make possible.
I would anticipate that there are going to be major discoveries that will come out of the Carnegie Institution as a result of having these new telescopes, and I look forward eagerly to seeing what they are.
Only by working in cooperation with one another were the partners in the Magellan Project able to make such scientific exploration possible.
The cost of large facilities, not just telescopes, are beyond the means of most institutions. The only way to acquire such instruments or facilities is to collaborate with people. And I suspect that Carnegie will not again build by itself a major telescope.
Like the early explorers, the men, women, and institutions of the Magellan Project have taken risks in order to see beyond the limits of our current knowledge. Now, it's up to the visionaries of tomorrow.
I'm just basically starting my career here, and I walk in and Magellan's ready. And that's quite a treat, but that's because the older people that were my age 20 years ago were thinking about Magellan back then. So it's important that I do the same sort of thing for the next generation.
People sometimes ask me, they say, why build big telescopes? You know, you can't answer that question. When the 100-inch was being built back in 1910, nobody had any idea about galaxies or the expansion of the universe, and you couldn't have predicted it a priori. In fact, nobody did whatsoever. But it was that telescope at that time that allowed Hubble to make these amazing discoveries. You build big telescopes because of what you don't know, not because of what you do know.